Okay, this is lesson 5.4. We're going to factor and solve polynomial equations. First, we're going to talk about some types of factoring. We have done some of these types of factoring, and some of them we have not. We have done GCF, which stands for greatest common factor. We've done general trinomials, which we're going to review in just a moment, and you'll remember what that is. But we have not yet done difference of squares or grouping. So those are two types of factoring that we're going to go over today, specifically with polynomials. Now remember, a polynomial is more than one term. So if I have x cubed, 7x squared, and 10x, then that's a polynomial because it has more than one term. This actually has three terms, which is going to be probably important to us later on. So let's start off with greatest common factor. I'm going to look at each of my terms and see what do they have in common. So these three things all have an x, and if I divide that x out and put it to the front, then I'm going to have x squared minus 7x plus 10. So I haven't done much to change this, but this has been factored by taking out the greatest common factor. If I do that with the next example, 3y to the fifth minus 75y cubed, this is divisible by y cubed because there's at least y cubed here, and y to the fifth has y cubed in it also because there's at least 5 of them. And then I might also want to double check here and see if it's divisible by 3. And I think 75 is divisible by 3. Let's check. 3 goes into 7 twice. Subtract, bring down. So yes, 75 is divisible by 3. So I'm going to take a 3 out also. So I'm taking out the biggest possible number and the biggest possible variable together as a group. So now when I do this, remember I'm dividing. 3y to the fifth divided by 3y to the third is going to leave me with y squared. 75y to the third divided by 3y to the third is going to leave me with 25, and that's it. The y cubes are going to be gone. So this has been factored using the greatest common factor, even though it's possible that, that this will factor further later on. Okay, so we're also going to look at the next type of factoring, which is when you have a general trinomial. How do I know it's a trinomial? Well, tri means 3. So trinomials are always going to have 3 terms. So if I have 3 terms, then I look at the last term and I say, what multiplies to give me 10 and adds to give me negative 7? So what multiplies to give me 10? 1 and 10, 2 and 5. Which of these could be worked to give me negative 7? Well, if I did negative 2 plus negative 5, it would still multiply to give me 10, and it would also add to give me negative 7. So you might recall this because we did this in sections 4.3 and 4.4 before we went on our break. So that's how you factor using general trinomials. We've done that before. We're going to do that a lot. So keep in mind 3 terms for general trinomial. Okay, so one of the types we have not talked about yet are the difference of squares. The difference of squares should say the difference of 2 squares. In other words, it's always 2 terms. So if you have 3 terms, you know there's no way it can be a difference of squares. The first thing you want to look for, of course, is that you have 2 terms, but the second thing you want to check is that each of your terms is something that's squared. So y squared is a square, and 25 is the same as 5 squared. So when you see the difference of 2 squares, you're going to write 2 groups of factoring. I have y squared minus 25, so I'm going to put y in each group, and I'm going to put 5 in each group because the square root of y squared is y, and the square root of 25 is 5. And then to finish this off, make one positive and one negative. That's how you factor with the difference of 2 squares. So for the next term, or next example, let's check this out and see if it works. 2 terms, 1, 2, yes. Are these both squares of something? Well, 16 is 4 squared, so that works. X to the 4th is x squared squared, so that works. And 81 is 9 squared, so that works. So since it is going to be the difference of squares, I'm going to make my 2 groups. I'm going to put the square root of 16x to the 4th first. So the square root of 16 is 4, and the square root of x to the 4th is x squared. So 4x squared goes at the beginning of both groups. Then I'm going to take the square root of 81, which is 9, put that at the end of both groups, and then make one positive and one negative. And that's it. We have factored using the difference of 2 squares. The next type is called grouping, and we're only going to group if we have 4 terms. So if you only see 2 terms and you only see 3 terms, then you know definitely do not group. But when we do have 4 terms, we're going to use grouping, and what I'm going to do is I'm going to group these 2 and I'm going to group these 2. So I'm going to write x cubed minus 3x squared, and I'm going to group them by putting parentheses, plus negative 16x plus 48, which I'm also grouping by putting parentheses. And I make between them, I make it plus. It just keeps it simpler because we want this negative to go with the 16, so we just put a plus here to kind of hold that place. Alright, so now what we're going to do is look for greatest common factor in each of these. So I'm going to look for our greatest common factor here. I'm going to look for a greatest common factor here. In my first grouping, my greatest common factor is going to be x squared. So if I take x squared out, it leaves me with x minus 3. Still have this plus here. In my second grouping, my greatest common factor is 16, but remember I have that negative, so what I want to do is I want to take the negative out. I don't really like for that first term to be a negative number. So we're going to take out negative 16, which leaves me with x, and then it leaves me with minus 3, because if I take 48 divided by negative 16, that's going to leave me with negative 3. Now here's what's going to happen with grouping, and this should always, always, always happen with grouping. I have common terms, x minus 3 in both places. So what I'm going to do with that is what makes this a grouping problem. I'm going to say x minus 3 is in both places, so I'm going to take x minus 3 out of both places, and then I'm going to write what's left. What's left? X squared minus 16. X squared minus 16. And that is a factored grouping problem. We'll do another one of these later on in the video. Okay, so we've looked at 4 types that are going to come up over and over and over again. There are 3 special patterns that come up just every so often. So I'm going to go through those kind of quickly. We're going to have the sum of 2 cubes. We're going to have the difference of 2 cubes. Notice the 2, so that means they would have to have 2 terms. And then we're also going to do factoring polynomials in quadratic form. And I'm going to explain that here in just a minute. So these are 3 more special patterns, kind of like we did in the last video. So first we're going to talk about the sum of cubes. Here's what the formula says. If I have something cubed plus something else cubed, I'm going to write the base plus the base. So A is my base here, B is my base here, so I have A plus B. Then I'm going to write the first term squared minus the first term times the second term plus the second term squared. Here's how I remember this. The first term squared and the second term squared, that's not too hard to remember. Then when you multiply A times B for the middle term, this sign always has to be opposite of this sign. So if it's A plus B, then this will be minus. And in a minute we're going to look at the other way, but this term and this term have to be opposite signs. Alright, so here's an example. If I have w to the third plus 27, is this the sum of 2 cubes? Well, is it a sum? Yes, because sum means addition. Are they cubes? Well, w to the third is a cube. And what is 27? 27 is 3 to the third power. So yes, it's the sum of cubes. So we're going to use our format. So to start out, I'm going to have w plus 3, because that's my base number here, and that's my base number here, w plus 3. Then I'm going to square the w squared, minus, because it has to be opposite. Then I'm going to multiply w in 3, so that's 3w, plus, this term is always plus, 3 squared, which is 9. So w plus 3 times w squared minus 3w plus 9. We're not going to spend too much time on these cubes, but it is very useful for you to at least see what the pattern looks like. Alright, now let's look at the difference of cubes. This one looks just the same as the other one, except this time it's a difference. And so the first thing is going to be minus, and the second symbol, the second sign, is going to be plus. So keep in mind, these two signs always have to be opposite. So if I'm trying to set up my problem, first of all, the difference of 2 cubes. So do I have 2 terms? Yes. Are they both cubes? Well, let's see. 64 is 4 to the third power. X to the third power is a cube. And 1 can be any power we want it to be, because 1 to any power is always 1. So when you see 1, it could be 1 squared. You could rewrite it as 1 squared. You could rewrite it as 1 cubed. You could rewrite it as 1 to any power you want to, because 1 is always going to be 1. So if we use our pattern now, we're going to use the base first of all. So 4 and x are the base of 64x cubed. It's a subtraction problem, which is a difference. So minus, and then 1 is the base of 1 cubed. Now we're going to do our second part. We're going to take 4x and we're going to square it. Opposite symbol. 4x times 1, which is 4x, plus, always plus back here, 1 squared, which is 1. So if I finish this completely simplified, I'm going to have 4x minus 1, 16x squared plus 4x plus 1. 4x in parentheses squared is 16x squared plus 4x plus 1. And in case you're wondering, for those of you that do wonder these things, this little trinomial that we're left with is not ever factorable. So once we get to this format, we are completely finished. That's factored. Okay, the last format we're going to look at is called a polynomial in quadratic form. How do you know if your polynomial is in quadratic form? Well, a quadratic has 3 terms. Okay, so first of all, it has to have 3 terms. If it's in quadratic form, then this exponent and this exponent match up because 6 is 3 times 2. And then the last term is a constant. So if this exponent is double this exponent and the third term is a constant, then you have something in polynomial, you have a polynomial that's in quadratic form. So what do? Well, we take 6 and we say what times what gives me 6 and adds up to be 5. So it could either be 6 and 1 or 3 and 2. We need this to add up to positive 5, so plus 3 plus 2. Well, that's how it's going to factor. Plus 3 plus 2. So what do we do here? Well, it's p to the 6th, so I'm going to use half of that, which is p to the 3rd, and that's my factor. Okay, sometimes you're going to have more than one type of thing happening, so the first thing I'm going to do is check for greatest common factor. All of my terms here are divisible by 4. I have 3 terms total. All of them have at least t squared. So I'm going to start off by finding the greatest common factor and factoring that out. If I factor out 4t squared, that leaves me with t to the fourth. Remember, when you take something out, you're subtracting. 6 minus 2 is 4. 20t to the fourth divided by 4t squared is going to be 5t squared. 24t squared divided by 4t squared is just 6 because the t squareds are going to cancel out. Okay, so we have factored out 4t squared, and then look what we're left with. This is a trinomial, and it's also in that general trinomial form because this 4 is double 2, and this is a constant. So we just talked about this. It's this quadratic form, even though it's not a quadratic problem. So the 4t squared stays where it was, and then I'm going to factor what's left. So similarly to the last problem, what multiplies to give me 6 and adds up to give me negative 5? So remember, this has to be positive 6 and adds up to be negative 5. So I could use, why did I do that? That's a 6. I could use negative 6 and positive 1, but do they give me positive 6? No, they don't. So I can't use that one. I have to use negative 3 and negative 2, because when you do negative 3 times negative 2, it's still positive 6. So this is going to be t squared, and this is going to be t squared, because t squared is half of t to the fourth. And in case you've noticed this, t squared also happens to be the middle variable. And that's it. That we used two different types. We did greatest common factor and we did quadratic form to get this completely factored out. That's what they say when they say completely factor this out. Okay, so how do you know which type of factoring you're going to use? Well, you should always, 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 always check to see if there's a greatest common factor first. If there is, factor it out. The second thing you're going to do is count the terms. If you have two terms, you're going to check to see if you have cubes or if you have squares. And if you have cubes, you'll check to see if it's plus or if it's minus. So it could be the difference of squares, it could be the difference of two cubes, or it could be the sum of two cubes. So if you have two terms, these are your options. If you have three terms, it has to be either a general trinomial, or it has to be in quadratic form. And either way, you look to see what multiplies to give me the end number and adds to give me the middle. So that's what you do for three terms. If you have four terms, it's going to be grouping. It only happens if you have four terms. So two terms will be one of these things, cubes or squares. Three terms is either going to be a general trinomial or quadratic form, and four terms is going to be grouping no matter what. Okay, so this is the last thing I need to add before I can finish this video. When we solve, we're going to factor and then set each factor equal to 0. So what are the steps? First, make sure that your equation is equal to 0. Second, factor it. Third, set each of those factors equal to 0. Alright, so I'm going to go through this quickly. Starting out, this is not equal to 0. So I'm going to say 4x to the 5th plus 216x minus 60x cubed equals 0. So I subtracted 60x cubed from both sides. Okay? Brought it over here. Now, the next thing I need to do, because I'm a math teacher and this is what I do, I have to have it in order. This is to the 5th power, then the 3rd power, then the 1st power. Then I'm going to go through my steps. Do I have a greatest common factor? Yes, I do. I actually have 4, they're all divisible by 4, and I have x, they're all divisible by x. So if I factor that out, I'm left with x to the 4th minus 15x squared plus 54 without an x. Notice I still have this equal to 0. Okay? So I have this quadratic form coming up again. So I'm going to have to go ahead and factor this also. So on my next page I'm going to have 4x, and then I have to figure out what my factors are going to be to set it equal to 0. So let's go back and look. What multiplies to give me 54 that adds to give me negative 15? So I'm going to say, how about negative 9 and negative 6? So minus 9 and minus 6. Multiply that, you get 54. Add it, you get negative 15. And this